Okay, here's what we're going to do. We're going to talk about a land breeze versus a sea breeze. We have two different terms. We have land breeze versus a sea breeze. Just in case you're wondering, I'm not trying to trick you. I'm just talking about a land versus a sea breeze. So a land, here's a house on the land. A little window in the house. And we've also got a sea, which means we're going to talk about ocean coming in here. A land breeze versus a sea breeze. So we're talking about ocean out here. Now, here's the thing. When we talk about a land breeze versus a sea breeze, there are two scenarios. There's one that has to deal with daytime and one that has to deal with nighttime. So in daytime, we have the sun. So I'm going to draw the sun up here, burning, and I'll highlight it up for you so you can remember that it's the sun. So there's the sun. This is daytime that we're going to talk about. So I'm going to put land breeze versus sea breeze, and I'm going to put day right here. During the day, when we looked at the last lab and we tested the sand and we tested the water, we found out that in our test that land actually heats up faster. Land heats up faster. Water heats slower. So that's the two differences that we saw in our chart. Land heats up faster. Water heats up slower. On the land, we're going to have all these little air particles right here on the land. These are air particles. And as the sun begins to heat up the day, what happens is the sand below it is hot. So sand gets hot, which causes this air to warm. And we know, just because you guys have seen this before, warm air rises. And so this warm air rises up into the sky like this. Well, if those air particles are going up, then over the top over here, the water slowly warms. So you have your land air over here, but the water air is going to be more dense. It's going to be packed together tighter like this, more dense. And you can see that all my air particles are closer together than they were on land. And so during the daytime, we have more dense air and we have less dense air. Well, because it's low density or more dense, we're going to say that, sorry, not low density, more density. If it's more dense air, then the pressure is high. So we're going to have a high pressure. Everything's pushing on itself. High pressure. This one over here is going to be less dense, so we're going to have a low pressure over here. And because of that, less dense, lower pressure, it's moving up. So we've got this L of low pressure moving up. I'm going to put an L for that. Moves up. And then we've got an H for high pressure over here. And that H for high pressure is going to cause everything to move up. No, it's going to move down. It's heavier. So what happens then is all these air particles, they're all packed together tightly. And they say, check it out. there's more room. Look, there's more room over there. So let's travel over there. So they do. They start to spread out and they start to move onto land like this. And so what you get is if you're standing on land right here during the day and you're standing here, you're going to feel a breeze of air move past you from out here. And this is going to actually end up becoming the wind right here. And it's coming from the ocean onto land, so it's sea breezing. So the sea is actually breezing onto land. So the sea breezes onto land. And so we give this the name of a sea breeze. This is called a sea breeze right here. This is called a sea breeze. A sea breeze. Very cool. That's why we have sea breezes right there.